similar to mathematics, right? The concept of precedence is pretty well known in algebra, right? Multiplication, divisions are performed, before additions, right? So you can have this, and this is how we represent it in computing. Multiplication and division, they have precedence over, right? Greater than plus or negative, right? So, or even modulus carries precedence over the additions and divisions. So basically C, C++, Java, right, Pythons, right, these languages extend the concepts to various different levels. So that's what this precedence is, right? Which one takes priority, right, over the other when you have multiple operators in the expressions, right? Now, associativity is a little different. Associativity is when, let's say, all of the operators have the same level of precedence or same level of priority. Which one takes place first, right? How would you evaluate the entire expression? Remember expression, right? Especially when you have complex expression, you can have assignments, right? This is called assignment expression. There's also, additions and multiplications, right? Divisions. Sometimes you have parentheses as well, right? You can have unary, you can have binary expression. So there are various different types of expression that makes up a complex expression. Associativity is a property. And then let's look at some of the examples to illustrate these better. So we have two expressions here. One of them is here and the other one is here. So we use printf to explain this. So in C++, this would have been cout, right? And then you probably include IO streams and whatnot. Let's look at this expression. There's 1 is 2 here. Now, expression number 1 here calls for, this is a standard algebra, right? When you have multiplications and plus, and obviously, what happens is this one takes precedence, right? A times B, right? Takes precedence before this C right here. That's what happens with respect to number 1, right? Number 1. Now let's look at number 2. Number 2 is exactly the same as 1 with the exception of the added parentheses, right? So as in arithmetics, and every time you have parentheses, that entire group of expression formed by the parentheses takes precedence, meaning this has to be evaluated first, right? So so this becomes, right, A times, right, B plus C, right? Not the other way around. So as you can see, 1 and 2 are totally different. So if you were to type in the whole, run the entire, programs, and you get 2 different values. So that's the reason. So this is a precedence. Generally, you should know, which operators takes precedence over the other, and there are various different levels. Let's move forward to associativity, right? So like I said, associativity is a little different than precedence. Associativity is, let's say if you have the entire expressions like this. So this entire thing, right, is an expression, right? Expression. Now this expression is complex expression, right? It has multiple pluses, minuses. Well, there's no minuses, pluses, but it has multiplication, division, modulus, right? And these. Now, when you have a complex expressions where all of the operators are of the same level of precedence, the evaluation happens from left to right. Okay, meaning the very first 2 operands with an operator is evaluated first, as in yellow, right? So this is the first group that gets evaluated, right? It's almost having a invisible parentheses. Now, once this entire evaluation is done, right? So this gives you what? This yellow outcome gives you 24, right? Then this 24 becomes the left side of a expression with respect to 24 divided by 4, right? So this green one, right? Now we're talking about this green one is 24 divided by 4. Now this becomes an invisible, right? There's an enclosed invisible parentheses that gets evaluated into what? 24, 4, this 6, right? So now let's move on to the blue region. Now this blue region is 6, right? Divides 4, right? This is actually not divided, modulus. So we're getting a remainder, right? 6 mod 4, right, gives you 2. So this thing, there's a, in the blue area, right, becomes a invisible parentheses enclosing 6 mod 4, which gives 2, right? So on and so forth, and then 2, right, times 5, right? This becomes the red region. Like I said, see, the associativity allows left to right, right, evaluation of, your expression, right? So expression is simply just, is a binary, right? That takes, this breaks down, right, into a binary, okay? So binary expression, a series of binary expressions, right? From left, right, to right. So that's how the left to right associativity is concerned. Whenever you encountered, multiple operators that are of the same, precedence. So let's move on to the next one, which is right to left associativity. Now, this is not frequently used, but once in a while you see them in code. I do not really recommend using this thing because, it's confusing, right? Not everybody, I'm talking about like developers are used to this kind of notations. Now, whenever you have some sort of assignment, this is what we call, right, assignment. Assignment what? Assignment expression, right? Why? Because you're assigning something, right, to it. So a plus minus equals a equals, right, a plus something, right? So b, right, multiply equals, is equivalent to b, right, equals b times something, right? So these are assignment, right, expressions. So you have actually 3 of these assignment expressions. And if you do that, you can actually evaluate this. This is totally valid. The order of evaluations happen from right to left, right? So from this direction all the way to the left. So this is the right, this is the left. Again, it's doing this. This is, if we recall, this is our binary expression, right? This binary expression having this, it gets evaluated. So yellow one evaluates first, and then whatever that value is, then tie into this green one, right? And whatever the outcome of this green one is ties into this blue one from right to left fashion. In fact, you can write a quick code snippet to, to validate this. So this is one example when you have this right to left, right? Associativity, right? Whenever you have this, something like this complex. So this J star, right, is not a J pointer or dereferencing, and it's none of that stuff, okay? This entire thing, right, is J equals J times 2, right? And so this is assignment expression. This is also another assignment expression. So we have 2 assignment expressions in one, making it this complex expression. So the associativity rule, right, says, right, this right one, right, which is J times equals 2, right, this evaluates to a value. This takes place first. So it's almost having a invisible parentheses here, starting from right. So J is 2, right? J times 2 equals what? 2, 4. So this gives you 4, right? So J basically equals 4. So whatever this is, this actually evaluates to 4, right? So I equals 4. That's basically it, right? So I eventually is 4. Now, if you look at this second, right? This is the first one, is the second expression. Actually, both of these are what we call statement. Statement is the expression with a semicolon, right? So there's a semicolons here. All right, let's look at this. So since that we have this associativity, this is right to left, this one gets evaluated first. So J is what? J is 2. J plus 2, J plus 2 is 4. So 4 is the value of J. So this is 4, right? And what is I? I is 1, right? So 1 plus 4, right, equals 5, right? So now you have I plus equals 5. So what is I? Right? So I is 5, right? So if you have I equals 5 plus 5, right? I becomes 10. So that's what it is. And J, we already talked about this. J eventually evaluates to a value of 6. So J was 4 before, so J equals 2 plus, right, 4. So J is 6. So you got to think 1 and 2, they're actually one statement after the other. They all evaluated in sequence. After 1, then 2, right? So this results in J equals 6 and I equals 10. So hopefully this is made clear. You can actually just write out this thing in the console and run it to see for yourself.